Hello, everyone. Today, we are going to get some more practice with more gas stoichiometry. I know this can be a very challenging topic, so I wanted to do a quick review video going over questions number 1 and 2 on the more gas stoichiometry worksheet. But before we even do the examples, let's draw Mole Island. So what makes something stoichiometry is that we're going to go from moles of one substance to moles of another substance. At some point in the problem, that's going to be true on this worksheet. And we go from moles of one substance to moles of another by using the mole ratio. And the mole ratio, remember, comes from the coefficients of our balanced chemical equation. Now, back in our stoichiometry unit, we also converted from grams of A and we converted to grams of B. And we did this using the molar mass. So if we're converting from grams to moles, we use molar mass. If we're converting from moles to grams, we also use molar mass. Now, in our notes yesterday, we added a new branch of Mole Island. And that new branch is that we can convert to liters of A or liters of B. And we can use, in order to do this, we can use 22.4 liters equals 1 mole of gas. But this green step from moles to liters or liters to moles only works at STP. So in some of our problems today, we are not going to be at STP, and instead we're going to use PivNert. So we can say not at STP. We're going to use PV equals nRT. Okay, so let's give some of these problems a chance. Okay, so our first one, we have ammonium nitrite, and it decomposes in a test tube, and it says that 511 milliliters of nitrogen gas is collected at 26 degrees Celsius. It says our pressure of nitrogen gas is 720 torr, and we want to know how many grams of ammonium nitrite were decomposed. Okay, so our problem and why this is a gas stoichiometry problem is because if you read in the problem, everything we're given is information about nitrogen, but it wants us to figure out something about ammonium nitrite. So what we need to do is we need to get our nitrogen to moles of nitrogen so that we can then do a stoichiometry problem and use Mole Island. So we need to solve for moles of nitrogen. And if you look at the problem gives us a volume, a temperature, and a pressure. And so we are not here at STP, so that means that we have to use PivNert. But luckily, it gave us all the information for PivNert. So for our pressure, remember pressure for PivNert must always be in atmospheres because of our value for R. So we need to take our 720 torr and convert to atmospheres. And if you remember, 1 atmosphere is 760 torr. So my torrs cancel. I do in my calculator 720 divided by 760, and I get 0.947 atmospheres. For my volume, it says 511 milliliters, but once again, in the ideal gas law, we need everything to be in liters for our volume, but luckily we just have to move our decimal 3 places, and so our volume in liters would be 0.511. And then lastly, our temperature, nothing's easy in this problem, is 26, but that's Celsius, so we want to add 273 to get Kelvin, and our answer in Kelvin would be 299 Kelvin. So after all of that, we can now plug into PivNert. So we have 0.947 times 0.511. Moles is what we're looking for, remember from our problem here, times R times T. So we're going to divide by R times T on both sides, and we're going to get a value for N. And when we do this division in our calculator, we should get a value of N of 0.0197 moles. But what is that moles of? If you look in the problem, everything we plugged in was about nitrogen. So this is still moles of nitrogen. And what the question is asking for is grams of ammonium nitrite. And so we can, if we go back up to mole island here, we are currently in moles of A, and we want to get to grams of B. So we'll use our mole ratio and then the molar mass in order to do so. So first up, mole ratio. So we have moles of N2. On top, we're trying to convert to ammonium nitrite. And so then our mole ratio, might help if we balance our equation, right? So let's balance our equation. So we have two nitrogens, 4 hydrogens. So we could put a 2 here, 2 oxygens, 2 oxygens. Whoop. Okay, we are now balanced. So don't forget to do that for your mole ratio. But actually, we would have gotten lucky. Our mole ratio is just 1 to 1 here because remember, it comes from our coefficients. So 1 and 1. And now that we're in moles, we want to convert to grams. So we will do molar mass. The molar mass of nitrogen is 14.01 plus 1.01 times 4. So 14.01 plus 4.04 plus 14.01 plus 2 times 16 is 32. And if you do all that in your calculator, you should get 64.06 grams. And so now we are ready to do this problem. Remember in Stoich, we set this up so our moles cancel, and the only thing we're left with is grams. And so our answer here to 3 sig figs is 1.26 grams of ammonium nitrite. And that, my friends, is a great gas stoichiometry problem. Okay, let's try another one. So here we have propane, and it's a gas that's sometimes used for cooking and heating. Most of you probably have a propane gas grill outside. And it occurs, the combustion occurs by the following equation. Oh, look how nice they were. They already balanced it for us. So we want to know what will the volume in liters of oxygen. So here I'm looking for liters. If we have the complete combustion of propane, and we have 0.35 liters at STP. Oh boy, at STP. This is our best friend to hear this phrase, because at STP, if we go back up to mole island, and let me erase this little bit from the last problem, my circles. Mole island, we can use our liters when we are at STP. So because this problem specifically says at STP, we can now use that. So if you look in the problem, we're starting at liters of one substance, and we want to get to liters of another substance. So we are going to get there by going to moles, moles to moles, moles to liters. We like when we see at STP. So we're simply going to start with 0.35 liters of C3H8. And using mole island, we can see that we're going to go from liters of C3H8 to moles of C3H8. And for any gas at STP, 1 mole is equal to 22.4 liters. And now that we are in moles, we can use our mole ratio to go from moles of C3H8. And it looks like I'm looking for information about oxygen. And my mole ratio is 5 moles of oxygen is 1 mole of propane. And then I'm still not quite done because I want to go from moles of oxygen to liters of oxygen because that's what the question was asking for. And no matter what the gas is at STP, 1 mole is 22.4 liters. So what's nice about this math in this problem, you can see we've got 22.4 on both the top and the bottom. So really it's just our mole ratio here. So we can do 0.35 times 5. 0.35 only has 2 sig figs. So, and the rest of these are infinite number of sig figs. So I'm just going to use 2 sig figs in my answer. If I do that, I get 1.8 liters of O2. You see how much easier the problems are when they are at STP, right? Look at the work comparison there. So we love it when it says at STP. So that's hopefully a nice little overview of gas stoichiometry. And now you can go ahead and complete the rest of the more gas stoichiometry worksheet. Thank you.